FastMCP implements a resource-oriented abstraction layer that transforms local skill directories into standardized MCP endpoints, enabling cross-tool discovery and retrieval of AI assistant capabilities. The protocol exposes each skill as a structured set of resources, main instruction files, manifests, and supporting assets, while maintaining platform-specific directory conventions through provider-based scanning. You're about to see how a client initializes a connection to a skills server and enumerates available capabilities using the listSkills utility, which abstracts the underlying resource discovery process into a straightforward iteration pattern. The code will demonstrate the asynchronous client setup, skill enumeration, and basic metadata presentation that forms the foundation for skill-aware applications.
From FastMCP import client. From FastMCP utility skills, import list skills. Async with client http://skills server/mcp as client. Skills equals await list skills client. For skill and skills, print skill name, skill description.
This code demonstrates the utility pattern for discovering available skills on a FastMCP server. The listSkills function acts as a convenience wrapper that abstracts the underlying MCP resource discovery mechanism, providing a simplified interface for clients to enumerate available skills. By using this utility, developers avoid manually parsing resource URIs and can directly access skill metadata like names and descriptions. The pattern follows the facade design principle, hiding the complexity of MCP's resource listing and manifest reading behind a clean async API. This is particularly valuable in FastMCP's context, where skills are exposed as standardized MCP resources, but clients typically need higher-level abstractions. The utility handles the protocol-specific details of connecting to the server, listing resources with the skill//scheme, and extracting relevant metadata from either YAML front matter or the first content line. This approach offers clear trade-offs. It simplifies client code at the cost of some flexibility, as developers using the utility give up direct control over resource filtering and manifest parsing. The pattern assumes skills follow the conventional structure with skill, MD, files, and standard metadata formats. For most use cases, where you simply need to discover and display available skills, this utility provides an optimal balance between simplicity and functionality, though advanced scenarios might require direct MCP resource operations. Let's break it down.
From FastMCP import client.
Imports the client class from the FastMCP module, which provides the primary interface for interacting with MCP model context protocol servers. This class enables establishing connections and performing operations like listing or retrieving skills from MCP-compatible servers.
From FastMCP utility skills, import list skills.
Imports the listSkills function from the FastMCP utilities module, which provides a way to retrieve available skills from an MCP server.
Async with client http://skills server/mcp as client.
Establishes an asynchronous context manager that creates a client connection to the MCP server at http://skills server/mcp. The async with statement ensures proper resource management, automatically handling connection, setup, and teardown. The client variable will be available within the indented block that follows this line.
Skills equals await list skills client.
Calls the listSkills function asynchronously with the provided client parameter, then awaits the result and assigns it to the skills variable. This retrieves a list of available skills from the MCP server using the given client connection.
For skill and skills, print skill name, skill description.
Iterates through each skill in the skills collection and prints the skill's name and description using an F string. The output format shows the skill name followed by a colon and the skill description. This is a simple display operation that outputs skill metadata to the console. The code demonstrates FastMCP3's facade pattern in action, where the list skills utility abstracts MCP's resource discovery into a simple async iteration. The client establishes the connection while list skills handles the protocol-specific details of finding skill / resources and extracting metadata. This trade-off sacrifices some flexibility for significant simplicity. You get immediate access to skill names and descriptions without manually parsing manifests or resource URIs. The pattern assumes conventional skill structures, but delivers an optimal balance for most discovery use cases, letting you focus on building skill-aware applications rather than protocol implementation.
The server whispers skill names while the client listens, but the skills themselves remain stubbornly silent.